Hi, I'm Rachel, and for my project, I did maple syrup urine disease, also known as MSUD. So MSUD is an autosomal recessive metabolic disorder which affects branched-chain amino acids. It is a form of organic acidemia. So this name is given from a certain sweet odor that an infant's urine will give off before properly diagnosed. Infants will appear healthy at birth, but soon deteriorate after accompanied with severe brain damage, which can become permanent. Death can occur within the first 5 months with severe cases that go untreated. The disease can be classified by its pattern of signs and symptoms or by its genetic cause. So the first classification is called the classic version of MSUD, and that is it forms shortly after birth and if left untreated, it can cause irreversible brain damage. And the other variations can occur later in infancy or childhood, as well as when an individual gets older. That's usually during times of extreme fasting, illness, or stress. Here, a fun fact is that before plasma amino acid measurements were available for diagnosing patients, they had to go off of the odor given off by an individual's urine or EOX and the other physical symptoms accompanied by the disorder. And the odor is caused by a compound, by buildup of the compound subtolin. So on this screen, I included the images of the amino acids that are involved in the buildup of the toxicity. So the genes that are affected by this disease are responsible for breaking down leucine, isoleucine, and valine. And when the amino acids are not able to be broken down by proteins made by the defective genes, then it can cause many of the severe symptoms such as brain damage or organ failure because these substances are so toxic to the organs. Next, I included prevalence, and in terms of prevalence, MSUD is a rare inherited metabolic disorder. It's rare because it's only prevalent in every one newborn out of 180,000 live births in the U.S. Although it can be more prevalent within populations with a higher frequency of consanguinity, and it also has a higher prevalence in children of Amish, Mennonite, or Jewish descent. So, moving forward, there are many symptoms that are caused by MSUDs. These symptoms are usually present in older adults, so these symptoms are based upon the severity of the disease. If left untreated in older individuals during metabolic crisis, symptoms can include severe, inappropriate, and erratic behavior, which can be accompanied by hallucinations. Anorexia, weight loss, and anemia are also symptoms. Other symptoms that are more typical are usually dehydration, lethargy, ataxia, seizures, hypoglycemia, so low blood sugar, and pancreatitis, which is swelling in your pancreas. The more severe symptoms are the neurological damage and damage to neurological functions, can also lead to coma or even death due to cerebral edema, which is swelling in the brain. And patients can also endure smaller illness that becomes more harmful and serious. So that's it for physical effects. So in terms of the inheritance pattern, the disease is an autosomal recessive inheritance. So the defective gene is found on an autosome and 2 copies of the gene, which one from each parent must be inherited to be affected by the disorder. So this means the individual can be carriers if they do not have both recessive genes. On the bottom, I included an image that I found online of an example of an autosomal recessive disorder, and in this case, both parents are carriers. Therefore, there is a 25% chance that the individual can be affected. So this disease is rare because, per se, if an individual did carry both dominant genes, then there'd be 0% chance that an individual would be affected. However, offsprings could still be carriers of the disease. Here's an example of the pedigree of an autosomal recessive disorder. I also found this one online. So in this case, individual 1 right here is a carrier and or is afflicted by the disorder, and individual 2 is not. However, so when it moves down to the children, none of the children are afflicted by this disorder. However, they may be carriers, and in this case, individual number 6 is a carrier because individual number 5, when paired with individual number 5, who is afflicted by the disorder, they do give birth to a child who is afflicted. This means that individual 6 did carry the recessive gene, which got passed on to their offspring. Next, I'm going to talk about the molecular cause. So on this slide, I included images of the BCKDHA gene, which is on top, and the BCKDHB gene, which is on the bottom. So the molecular mechanisms that cause the disease is that MSUD is caused by a deficiency of the branched chain alpha-keto acid dehydrogenase complex. So this causes the buildup of branched chain amino acids. They're toxic byproducts that are found in the blood and urine. MSUD can result in mutation of any of the genes that code for the enzyme subunits. The genes that are affected by BCKDHA and BCKDHB, BBT, and DLD. So in this condition, the defective gene or genes are found on the autosome. I included in the slide where. And on the next slide, I also have another image of BCKDHA. And so BCKDHA and BCKDHB form subunits that combine to form a complex, which is called the E1 complex. So their normal job is to form this composition, which is in charge of breaking down the amino acids. The breakdown of amino acids is used for energy. And also, I forgot to mention that the individual consumes these amino acids through their diet. So mutation on the gene causes a decrease in the enzymes that break down the branched chain amino acids because BCKDHA and BCKDHB cannot combine to form the complex, which affects the structure and production of the proteins that will function to break down those amino acids. Lastly, so on this slide, I included all the genetic testing that is available in order to diagnose an individual with this disorder. You can read through those quickly. And then, so finally, I'll just talk quick about like furthering on the genetic testing, and that is that it is testing is mandatory through the ACT screening test. Because if this disease goes untreated, like I've said, the infant can go into a coma and die due to the buildup of those toxic amino acids. The screening is usually done postnatally on the newborn, and this test can also recognize 30 other genetic diseases, which is also pretty cool. Testing is extremely important, and all states require it, just because, as I've mentioned before, the irreversible neurological damage that it can cause to an individual and the other damage it can cause to the rest of their organs. These are my references, and that's the end of my presentation. Thank you, and I really enjoyed this class.